Assalamualaikum warahmatullahi wabarakatuh, and a very good day. I bid to my supervisor, Sir Chong Chiman, and also examiner, Dr. Mirza. My presentation is about the porosity studies and impact of diagenesis parameters on reservoir in field effects, also in Central Luconia and Sarawak. The outline here is the introduction, methodology, results and discussions, and lastly my conclusion and recommendations. Starting with my problem statement, the local porosity study here at field effects is very dated. Porosity studies are also done only at a bigger scale. And lastly, correlating porosity studies and diagenetic processes with reservoir quality has not been emphasized at all in this field. Therefore, with the objectives to perform the background study on Central Luconia itself, to determine the phases, diagenesis and the rock properties here in the carbonates of field effects, and lastly to evaluate the reservoir quality of carbonate rocks. Moving on to the background of my study area, looking at the northwest Sarawak basin is the Balingian province, and at the center here is the platform of FX, which is also located nearby Central Luconia complex. Furthermore, field FX is a middle Miocene flank carbonate platform. Architecturally, it is elongated from southwest to northwest, measuring 4.5 to 7.5 diagonally. The contours here the steep contours here are due to the paleoclimates of summer winds interchanging with winter winds, which also affects the internal platform architecture and also sediment distribution. Next is my methodology, where the first is my sample descriptions, my microphysics classification is after that, and then is the porosity and diagenesis correlation, and then is the integration of the positional environment, where the first result here is through the sample description. The given 10 sections are total at 36, 18 are used and 2 are used for every depth, ranging from 4,010 feet to 4,711 feet. Generally, this 10 section analysis was done through the physical descriptions, where the elements can be seen here are pores, matrix, dolomitization class, bioclass, and cementation. The description of pores are blue, in characterized as blue. Matrix are characterized as fine-grained mud, also sedimentations. Dolomitization are by white class. Fossils or bioclass comes in different shapes and sizes. And lastly, cementation are also due to the bright and pinkish red cements, which are usually calcinations. For example, here in depth, the first depth, which is 4,010 feet, 2 thin sections are picked, and then the observations are recorded here. Ultimately, going into this table, which are due to determining the composition range, the Dunham classification, components, pore types, diagenesis, and lastly the nomenclature of phases determination, which uses the combination of Dunham name and main components, which are the main fossils in here, which in this case red algae and packstone due to the grains spotted, combining them into red algae packstone. Next result is the classification of all the microphases I have encountered, which there are 7: red algae packstone, forum floatstone, forum coral rootstone, forum packstone, coral floatstone, and two rootstone, coral packstone, and lastly coral floatstone. Here we can start to see the general trend and the distribution, especially in the pores, the mineralogy, the pore types, and diagenetic alterations. However, in this next result, the table has been downsized into 1 phases per cell, and therefore the composition ranges are average. Here in the bracket values are averages, and also here is the ranges of the composition. Pore types are also considered as important here, but the most important is highlighted in this blue bracket and this blue box, which are the diagenetic alterations, specifically described as more on amount of diagenesis in light, moderate, or heavy, and then concluding them into a porosity category, which also affects the reservoir quality. Starting from the first porosity category, which is excellent, averaging at 24.7%, ranging at 10 to 35%. Good started with 20%. Moderate is averaging at 12.5%, but can be as low as a range of 0 to 20% range. Poor category started from 5.6% average and ranging from 0 to 10%. For the diagenesis, we can correlate with these 4 thin sections here. The excellent category here, they are mostly heavy dissolution and leaching. As you can see here from this thin section, there are very wide pores here. Both of these have very heavy dissolution and heavy leaching. Good category have moderate diagenesis altogether here. The moderate category in this third thin section, which is light to moderate cementation and dolomitization. Here we can have an early conclusion that dolomitization is the one that enhances this porosity here, which can cause the moderate porosity averaging at quite high 12.5%, at least double the value of the poor porosity. Lastly is the poor category. Here is the thin section which are full with mud. The category here is also having almost no pores at all. However, the solution detected here are quite light to moderate cementation. All of this correlation can be integrated into the final result, which is the deposition environment model, where the distribution of the parameters of microphases, diagenesis and petrography can be seen with a general trend. The green bar here indicates the abundant occurrences and the less abundant occurrences. Starting with the first depositional environment, which is the off-reef, depositional energy is very low here, and the observed microphases is the coral floatstone and coral rootstone. Cementation is the only diagenesis that are abundant here. Due to the texture of floatstone and rootstone, this is because the high deposition of mud, low deposition energy and wave, and also the porosity are very low due to the high cementation and also high deposition of mud. Therefore, a very poor category. Next is the fall reef, which is counted as a moderate deposition energy due to the wave energy that here break apart at this section here. This section here is also abundant with packstone textured thin sections. Cementation and dolomitization are also a very abundant diagenesis here, but it is emphasized on the dolomitization, where the main cause of the porosity here higher than the off-reef is because of the dolomitization, which is a porosity enhancing process. Packstones are abundant here due to the grain supported and abundant in skeletal grains here. Average at 15% porosity, this reservoir quality is categorized as moderate to good. And lastly, the depositional environment here is the back reef and lagoonal protected. This reef barrier will be protecting the waves from the lagoonal area. Therefore, the energy is very low here. The observed microphases are coral floatstone to rootstone, and lastly foreign floatstone. The only diagenesis processes here that are abundant are dissolution and bleaching. Due to the very shallow environment here, when sea level decreases, the amount of subaerial exposure area will also increase. Therefore, exposing to rain and meteoric waters will cause further dissolution and leaching. This will cause porosity destroying processes, and therefore causing a very high average porosity, and therefore a very excellent reservoir quality. All in all of these thin sections ranging from 4,000 to 4,010 feet to 4,711, 7 microphases have been identified. Porosity inferenced and concluded as very affecting to the diagenesis, and therefore affecting the reservoir quality. Deposition of sediments such as mud should be taken into consideration also, especially in deposition environment. And lastly,